Well, it's a real pleasure to be here. I'm really excited to get to share some new work with people today. I'm going to share about some ongoing work, some work still in development. So I'll look forward to questions and feedback. So as mentioned, I co-direct the Vanderbilt Music Cognition Lab together with the esteemed Raina Gordon. And I knew Raina was going to be getting tons of shout outs during these talks because she's been such a force in the field. Raina's very complimentary to me, so I have the mic. I get to be very complimentary to her now. But this is a talk that is actually not together with Raina, although of course she inspires me every day, but I wanted to get my Raina time in. So that picture is my son and Raina's daughter. Yeah, right? And they're still friends, and they still both play piano. And I think there's a lot of individual differences between the two of them and how they're learning piano. It doesn't really have anything else to do with my talk, but it's children and it's music and social bonding and sharing, so I just wanted to throw it in. All right, so what am I actually going to talk about besides my own child? I'm going to talk about speech and song and early development. I'm going to talk a little bit about assessing autism in infancy and some patterns of attention during speech and song. And this is exciting to me as an assistant professor because I now have amazing trainees that I get to work with, and so I want to showcase, so they can't be here today, but a lot of the work that I'm going to be sharing has really been driven forward by these amazing people, including Camila Alviar, Manash Sahu, Noah Fram, and Shiv Chawla. So I'm excited to get to represent a lot of the work that they're doing. Okay, we're getting close. It's not lunchtime yet. We've been sitting. So let's get a little bit of show of hands. So who here studies music in some capacity? Good. OK, people are listening. I thought we'd get a lot of hand raises, so that was a test. Who studies or works with infants? OK, a couple. Who once was an infant? All right, OK, good. All right, so you got to keep you on your toes, right? I'm not going to lie. I put this talk together at like 4 in the morning, so it's partially for me to stay awake, too. OK, anyone here work with kids with autism? Oh, all right. So maybe I'll have something different to share with you. OK, so what do we know about speech and song and early development? So maybe some of you said you worked with infants. Everybody pretty much agreed they had once been an infant. I don't know if you can remember this period of your life. But we know that speech and song are important for attention capture and regulation. We know they play important roles in arousal regulation for infants and also their parents. They're also important forms of communication. And with that, they help support language development as well and other forms of communication development. But we also know there are some differences. So young infants will attend longer to infant-directed song than infant-directed speech. They'll also have more arousal regulation. A lot of the work that's been initially done in the field, really focused on them as sort of auditory signals, but I'm going to be concentrating a lot on visual social engagement and really highlight the way we visually engage when people sing to us and speak to us. And with that in mind, when the studies have compared that, for example, children's attention to infant-directed song versus speech, we tend to see these most pronounced differences when we have the audiovisual elements of the stimuli, so when they have those visual engagement components. Oh, and I have some infant accompaniment, it sounds like. I couldn't have planned it better. So he may have a lot of thoughts to share about, so if you want to translate that, he's maybe have that embodied experience right now. OK, so compared to regular adult-directed speech, yes, you have so much to say. Infant-directed speech is slower, it's more repetitive, it's more rhythmic, it has a higher pitch, more variable pitch contours, and then it also has these really exaggerated facial expressions, and he agrees, so that's great. And then infant-directed song, compared to infant-directed speech, is even slower. It's even more repetitive and more rhythmic. The facial expressions are super exaggerated. We know that caregivers smile more when they're singing to their infants. It also has increased jaw displacement, so you have sort of larger visual signals that are going on. So it's just sort of interesting. You have these two stimuli, and they're both kind of increased in these kind of attention regulating capacities compared to adult-directed speech, but song is kind of further in on the spectrum in terms of how much it's really using these types of sort of signals and features. OK, so what do we know about autism in speech and song? So we know that children with autism have reduced attention to speech. And in particular, we know they have reduced attention to faces, but particularly faces that are accompanied by speech. So if you compare studies where they look at static faces or faces that aren't making any sound versus faces that are also having speech accompanying them, we see more pronounced differences in autism versus non-autistic children when you have that speech accompaniment. At the same time, while there's reduced attention and interest in speech, children with autism do still prefer infant-directed versus adult-directed communication, so that more rhythmic, more interesting, more prosodic is still preferred, even if the overall preferences for it is reduced. And then when we get into things like song and music, there's some studies that suggest that children with autism have maintained attention to song and music, despite having reduced attention in speech situations. And for some children with autism, there are some really specific interests in music. And so most of these studies have been done behaviorally, but there's also some neural studies looking at, for example, brain connectivity or responsiveness to speech versus song, and they tend to, again, see more similar patterns of functioning in autism for song than for speech stimuli. Okay, so if you've seen me videos a lot, so I apologize, but a picture's worth 1,000 words, a video's worth much more. Here is a girl, this child actually has a dual diagnosis. She has autism and Williams syndrome, but her profile is very consistent with autism. This is what happens when she's playing with an object. If I can find my mouse.
I see. You do like this thing before you, don't you?
All right, so she's really interested in that spoon. She's very focused on that object. But as you can see, what she's not doing, she's not sharing that interest with others, right? So typically, if kids are really interested in an object, they might do joint attention. They might look up to their parent or somebody else in the room to be like, hey, do you see this? And isn't this cool? And kind of share that enjoyment. And she's sort of not doing that in this situation. This is what happens when her mom sings to her.
What does Isabella do on the bus?
That's a gesture.
Isabella's on the bus going up and down, up and down, up and down. Isabella's on the bus going up and down, all through the town.
All right, so there's a lot of social communication features happening there. So she gestures, she goes up when her mom asks her. She shifts her gaze between, that is me many years ago, between her mom and me when I laugh, and then also just kind of like, whoa, look at the song going on. We blurred their faces, but she actually looks up at her mom when her mom pauses to be like, hey, continue. So obviously I know there's many different things, that doesn't have any objects, so these are different types of interactions. But still you can just see that, for this child, song is really capturing her attention. Okay, so most of the work that's been done has been with toddlers or older children, because in general, autism, well, we could get into a big ethical discussion about when it gets diagnosed and why, but in general, toddlerhood is more when autism gets diagnosed. But autism is a developmental disorder. And so if we want to understand how autism is unfolding, we need another way to look at autism in infancy, because the prevalence of autism is about 1 in 44 individuals. And so, if you wanted to test like a huge sample of infants, you would have to test so many kids to get a big enough sample of infants with autism. So the way the field has handled this generally, historically, has been what's called baby SIBS designs. Are people familiar with these? Can I get a show of hands? Okay, a couple people. So autism has a huge genetic component. It's a very complex genetic disorder with sort of multiple genetic inroads in. But we know that because of this, children who have older siblings with autism are at elevated likelihood of developing autism themselves, or developing some sort of other developmental or communication or sort of subthreshold autism symptoms. Historically, what the field cites is about 1 in 5 children who have an older sibling with autism will go on to develop autism. That paper is now over 10 years old, and the kind of general consensus in the field is that that's probably too low, and as our diagnostic instruments and understanding of what autism looks like in infancy has increased, that we're seeing higher rates of that. So anyway, so there's a huge number of these sort of baby SIBS designs, and we can chat more about that. But that's the way we can sort of build up and amass a sample of infants with autism from very early in life when we want to study, for example, attention to speech and song. So another fun thing about the autism field, and since it turns out not a lot of people in that here in that field, is that we have siloing. We know that's a big problem in research, and there are certainly many people who study music and autism. But there's a lot of people who just study development and autism and wonderful components of autism, and turns out they actually often use music and song. They just don't necessarily realize it or think about it that way. So you can't just like do a PubMed search for music or song. You kind of got to dig into their methods, and you'll be like, aha, you did study song. Like you told me you didn't, but you do. So this was a study where they had a sample of children with, so ASD is infants, these are infants 6 to 12 months, who go on to develop either autism, HR stands for high risk, so those are the elevated likelihood children, and the C is for they have some sort of complex outcome. The high risk or elevated likelihood children who go on to have typical development, and then low risk or low likelihood children, so general population, who have older siblings without autism who are typically developing. And they did a number of different interactions with the kids, a dyadic bid, which is infant-directed speech, so they engaged with the child. They played a peekaboo game, they did songs, they tickled them, or they did a toy, and they coded, these were for like a minute each, and they coded children's attention to the face. And just what I want to highlight here in these two conditions is you can see in the song, which is the middle arrow, probably should have color-coded it, sorry, that attention does not differ amongst any of those groups to the face of the person engaging them, and that it is also quite high. But then if you go to your left for the dyadic bid, that's the infant-directed speech, you can see attention in everybody is reduced compared to the song condition, and it's particularly reduced in these infants who are going on to develop autism or have other complex outcomes. So we have some evidence already from some direct studies that infants with and without autism, again, engage differently to the face during song and speech, and that this seems to be more differentially affected in speech than song. Okay. So we, while this was going on, while that study came out, we had been working on this other study. This was done with my colleagues at Emory who have been running baby SIBS studies for a very long time. And so we have been able to amass a pretty large sample. I'm going to focus in this first study on all males. Yes, there are sex differences and can get into all that. So we actually have 65 infants who are going on to develop autism, and all of them have sort of diagnostic confirmation. And then we have 143 males who are typically developing. And so the kids were eye-tracked longitudinally, so they watched videos while we collected their eye gaze information from 6 to 24 months, and they were engaged with a variety of different types of stimuli. So some of them were infant-directed speech, like this.
For dinner, we're going to have chicken and broccoli.
They're much longer than that, but just for time. Song.
Old MacDonald had a farm, E-I-E-I-O.
And then also, something that hasn't been studied a lot, but a typical way, especially with young kids, that we really engage is we use gestures. That gets them really engaged. So here's an example.
The itsy bitsy spider went up the water spout.
Oh, everyone seemed to like that. I'd be like, ooh, yeah, right? It's engaging for adults too. What's she going to do next? I don't know, but we'd have to see. Okay, so children watched sort of a variety of these videos. There are actresses doing all the different things. I know it looks like we only have a different actress in that condition, but no, like there were different actresses doing all the different things.
For dinner.
Okay, and so basically what we do is for every frame of the video, we look at what are the coordinates of where the child is looking, and are they attending to the face? Are they attending over anywhere on the screen? So are they paying attention to the stimulus? And then are they attending to the face of the stimulus? So either the eyes that are in orange or the mouth that is in green. Okay. So what happens? So I'm going to start just by showing you some typically developing infant results. So you have in blue the song with gestures. That's that itsy bitsy spider that you were all so engaged by. Turns out the infants were really engaged by that too. Okay, so they all look longer when there's gestures happening. With song, makes sense. There's like the most stuff happening on the screen. But then in orange, you have the song without gestures, and in green, you have the speech without gestures. And so infants attend more in both song conditions to the speech conditions. But it's interesting, you can see in typically developing kids that especially as they get older, towards that end of the second year of life, their attention to speech is continuing to increase, whereas in song, it seems to be plateauing. What do we see in kids with autism? So these children, as you can see, are looking less overall compared to the typically developing children. But you see some of the same kind of general patterns where that they are attending more to the song than the speech conditions. Thank you. I concur. OK. This is great. Laura, if you could bring them to all talks in the future, that would be amazing. OK, so then we looked at what happens specifically about attention to faces, right? So not just are they looking anywhere on the screen, but are they attending to the face? So something that, again, we have typical development on the left and autism on the right. Yep, from your angle. And so something that we see is, not surprisingly, in blue is the song with gestures. And you can see that children look less at the face then. Well, good, that makes sense, because there's also a gesture to look at. But you can see that overall facial attention is somewhat similar in the speech without gesture and the song without gesture. Those are our green and orange lines, respectively. But you can see that the face looking does change with age, again. And you can see in that second year of life, I don't know if you guys can see my have a cursor. Oh, you do. Look. OK, perfect. You can see that, again, that in children who are typically developing, you begin to get this divergence where speech, again, becomes sort of really salient. But in autism, we're not seeing that. In fact, their sort of attention is really reducing. OK, so overall, this sort of longitudinal eye tracking study kind of generally is similar to some of the results that maybe hadn't meant to look at song, but ended up looking at song in the literature previously in regards to this sort of increased attention overall to song. But what we really wanted to get, and one of the benefits of using eye tracking, is we could get sort of more fine-grained in terms of where children are looking. So in particular, we were interested in children's attention to the mouth, because attention to the mouth region supports language development. And we know that children increase their attention to the mouth over the first year to year and a half as they're getting sensitive to cues that are going to be really important for language learning. So there's been some studies from this in typical development. So this is sort of a canonical study from David Lefkowitz's lab, where you can basically see that above the line is sort of preferential attention to the eye region. Below the line is preferential attention to the mouth region. So early on, children look at the eyes more, but then over the first year of life, they begin to look more at the mouth. Some other work from my colleagues at Emory are using a slightly different method, but showing again this is all from 2 to 24 months of age. This is typically developing individuals. You can see that their mouth looking, where my cursor is now, is sort of increasing over those years of life because children are, again, using the mouth and sensitive to the mouth for these language learning and sort of communication cues. But people had not looked at whether or not this differs for speech versus song. And I think this leads to some potential hypotheses. So it could be that we know that some of the redundant and amodal cues that infants are sensitive to from very early in life, things like tempo and rhythm, synchrony and affect, are really, really salient in the mouth region of a face. And we know that in song, if you remember from 10 minutes earlier in this talk, that song sort of presses the gas on all of those types of features, right? It's even slower than speech. It has even more rhythmic predictability. It has even more synchrony, and it's more positive. But on the other hand, we also know that social emotional information, song plays such an important role in sort of that arousal and social processing, and that's going to be very, very salient in somebody's eyes. So does anybody, I'm curious if people think mouth looking in infants is going to be greater in speech or song. So do people know the results? Do people see any of this presented before? No. OK, so let's take a poll. If you think mouth looking is going to be greater in speech than song, Raise your hand. All right, okay. If you think they're going to be the same, raise your hand. Okay? If you think mouth looking is going to be greater in song than speech, raise your hand. All right. And Devin's going to weigh in. No, okay. All right. Thought maybe he had something to say. Okay, so so now we're not just looking at the face region, the sum of the orange and the green. We're looking at, are they looking, when they are looking at the face, are they tending to look at the eyes, the orange part, or the green, the mouth part? Okay, so what do we see in typically developing? Well, it turns out that for the last group, you guys were right. So in infant-directed song without gestures, kids are much more likely to look at the mouth than they are during infant-directed speech. So song is really driving children's attention to the mouth much more. It's important to know that you can see, we start this at 6 months, but early on, children are still preferentially looking at the eyes, but this goes all the way back to 3 months, which is the earliest we've looked at it, that song is always increasing children's attention to the mouth relative to the eyes. This is in typical development. What happens in autism? Well, it actually looks pretty similar. Okay? So children with autism are also looking to the mouth more during song than during speech. Okay. So take a pause for a sec. So just some general things that we've found. We've seen that overall in autism, we do see decreased attention, and they don't have that increasing attention to speech with age. We see decreasing attention, fixation to the face in particular, and again, especially in this sort of second half of the second year. Well, that's confusing. 18 to 24 months, that's maybe less syntactically complex for all the grammar folks. In 18 to 24 months, right, they're not seeing this kind of continued engagement and interest in speech. We actually see some similar fixation amounts to the mouth. But I want to posit that even when we're seeing some similar behavior, like mouth looking, these may be resulting from some different mechanisms, and they also may have different adaptive value. So just because the children may have similar proportions of mouth looking time or also have similar increases of attention to the mouth during song versus speech, that doesn't necessarily mean they're doing that for the same reason or getting the same sort of adaptive value, like language learning process from it. So we've been starting to look at that. This data is still under development, I would say, as I was learning, working through it. So we have, this is a subset of kids from who I've presented previously, and we've broken the kids now. We have our typically developing children. We have children, these are infants with autism, but who are going to have low expressive language outcomes, and children with autism who are going to have high expressive language outcomes, by which I mean language outcomes that are in the typical range. And we're looking now during this first year of life from 3 to 12 months, so I just want to orient you to that. So first, if you look in the typically developing children, you again see just what I showed you before with the overlapping sample, so good quasi-internal replication. That children look at the mouth more for song, here in orange, than for speech. This is only song without gesture. That's what we're focused on. When we look at the kids with autism who are going to go on to have lower language, we actually see that their patterns look pretty similar, right? So they're also having this similar increase between 3 and 12 months of age, but that the increased attention to the mouth is occurring particularly for song than speech. When we look at kids with autism who go on to have high expressive language or language outcomes in the typical range, we actually see that they're also increasing, and they also have this differential effect, but actually at a lower rate than the children who are either typically developing or from the children who actually go on to also have language delays. So why do we see differing trajectories? This is something we're really interested in probing further. So I don't have this data yet in autism. As I said, this is ongoing projects, but I want to give you some hints of what we might be seeing from our work with typically developing infants. So we leveraged a really large sample of almost 300 non-autistic, typically developing infants. This is now a mix of males and females. Again, nice internal quasi-replication, or replication, but quasi-internal because it's overlapping, but not completely overlapping sample. We again see from 3 to 12 months of age that infants are increasing their attention to the mouth, and that this increase is happening faster in song than speech. But again, as a reminder, I promise I'm not doing a quiz later, but if I was, this would be a good question because I've brought it up 3 times now. But repetition's our friend. We'll all remember it, right? So song is slower. It has increased rhythmic predictability. It has increased audiovisual synchrony, and it has increased positive affect and smiling. So we were curious if maybe some of these features might be some of the reasons why we're having increased mouth looking in song versus speech. So when we look across song and speech together, what we see in these typically developing infants is, yes, these features are all associated with mouth looking. We have tempo here, rhythmic variability, audiovisual synchrony in the mouth, and smiling, positive affect. And what you can see, maybe it's a little hard, each one of these lines, we've broken it down by different ages. And so these lines at the top are the older kids, like 12-month-olds, and these lines at the bottom are the younger kids, like 3-month-olds, are that all of these features are indeed contributing to mouth looking. But they do change some over development. So in particular, features like tempo, which is our, if you have to bet on something, bet on tempo. It seems to be the biggest, have the biggest influence here. Kids are increasing their mouth looking for songs with slower tempo, and this is really also apparent in the older individuals. Here are these upper lines. We see a smaller but significant effect with rhythmic variability and with audiovisual synchrony. So more rhythmically predictable, less variability, there's more mouth looking, and more audiovisual synchrony in the mouth, more mouth looking. And then actually what we see in younger infants is when smiling and that positive affect matters. So I think that's exciting, thinking about, again, those roles of attention regulation and emotion regulation and what might be driving sort of interest in these different types of features. So we're really interested to kind of continue this work in children with autism, and maybe we'll have results for a future conference. Okay. I didn't time my talk in advance, so I'm going to skip a bunch of stuff, but we'll just clue into it, and because I talked about Raina for too long, but it was worth it. No regrets. Happy to talk more about Raina or science afterwards. So one reason, as I was sort of positing, is we're seeing these, both similarities and differences in attentional profiles. And I sort of honed in on the mouth region because of it's important for language learning. But I hope what I was showing you with some of the differences based on children's language outcomes, and by hinting about maybe these roles of these different features, right, is that some things may be happening for different reasons or from different mechanisms. I want to give you another example of how we can see some somewhat similar surface behaviors in autism, but may be happening for underlying different processes. So what I showed you before was all about amount of visual attention. But I would also argue, as I think like this entire room is interested in rhythm and timing, people would agree, it's not just what you attend, but it's also when you attend. And it turns out that's really, really important for social information, because we cannot attend all the time equally. That would be exhausting. Maybe that's how you all feel, hearing me talk very quickly to you for 28 minutes, right? But what we know is that when you attend is really important, and that's really important for social cues. So we just published a paper that I feel like I've been working on for my whole life, but it finally came out last week or 2 weeks ago or something, where we sort of leveraged our eye tracking paradigms to infant-directed singing and how that entrains infant social behavior. And in the interest of time, I'm not going to sort of focus in on that today, except to say that here we looked at this in this paper from infants at 2 months of age, when infants are sort of first contingently responding to others, and then again at 6 months of age, when infants are really social pros and doing lots of face-to-face interactions and musical games. And basically, if these middle lines here are the beats of infant-directed singing, children are increasing their eye looking. They have a higher likelihood of looking at the eyes of the singer, time aligned to the beat. And we see it as early as 2 months of age, but it substantially increases by 6 months of age. Okay, so in the interest of time, because I want to be conscientious to y'all, we've repeated this experiment now. It's ongoing, working in toddlers with and without autism. And what we have actually is the toddlers watching both nice, regular videos of infant-directed singing, sort of like I showed you before. If you harken back in your memory. And then we also had them watch versions where we've experimentally jittered them. So we've had some nice examples of irregular rhythms, but we've done it with things like this to give you an idea.
Mary had a little lamb, little lamb, little lamb. Mary had a little lamb, its fleece was white as snow.
Yeah, like super annoying, right? All right. All right, so when the infants, the toddlers with and without autism watch just the regular singing, we have our typically developing kids up here on the top. You can see time aligned to the beat that they're increasing their eye looking quite a lot. Actually, there's a little bit of anticipation, which is really cool. We're seeing some developmental things there, but to be followed up. And then actually in our toddlers with autism, we are still seeing a small but significant effect of this entrained eye looking. The children are still looking at the eyes. They're more likely to look at the eyes of the singer at the beats of the singing when we have sort of this regular singing. What happens, though, when we jitter the singing and it's now become unpredictable, well, it reduces in both groups. But you can see in the typically developing toddlers, we're still getting a pretty strong signal. So they're actually still kind of able to, I'm going to say entrain, but I don't really know that I think it's entrainment, so we can parse that later. But they're still able to follow along and increase their looking at the eyes of the singer when you have this unpredictable singing, time aligned to the beat. But again, we've made the singing really unpredictable. But when I say the beat, I mean where those events are happening in regards to that important social information. In toddlers with autism, you can see it's barely a whisper. They're really struggling with it. But what's so interesting about this is, there's many different ways to do the task. And so it could be that, we've made it jittered, we've made it unpredictable. And so you could use a strategy where you're kind of saying, okay, this is the inter-onset interval, and I'm trying to extract that, and you kind of keep using those durations, and you kind of keep averaging them across all the ones you're getting. Or you could be doing sort of more of a regression prediction where you're going to sort of use those timings of onsets of events that have happened to predict the next one. I'm not explaining this well. I'm out of time. We can talk more later. But what's so cool is that you can see in our typically developing toddlers, their best model seems to really be when we look at sort of the actual event times of where we've moved the beats to. So they're really tracking that social information. The toddlers with autism are not doing that. They're actually highly all focusing on this predicted timing when we use this sort of regression effect. So they're using sort of timing of events to predict when the next event will happen, even if, spoiler alert, there's not actually a social cueing beat event happening there. Okay. So what are some implications of this? Rhythmic predictability of song helps structure adaptive behavior, eye looking in this situation. We seem to have sort of reduced accommodation of unpredictability in autism, and that the toddlers with autism are really using a different predictive strategy. Okay, some take-home messages because I'm out of time. It's really important that we consider both the content and timing of visual attention. There are going to be both similarities and differences in visual attention during song and speech in autistic and non-autistic infants and toddlers. And these differences really emerge over development. So when we look at things cross-sectionally, we may not see as many differences, but when we look at trajectories, we may really see some differences emerge. And there's these similar surface behaviors, but they may be driven by different underlying processes or may have different adaptive values. And we saw that by looking at differential attention overall. We saw that by looking at what features might be driving things, by looking at how kids can time things, and by thinking about what's driving these events. And maybe some of this has some heterogeneity in autism. As a final thought, I would hope that, especially for people who are doing visual experiments too, you really consider stimuli design. So when you go into the literature, there's just a lot of speech. And then when you look at it, sometimes it's infant-directed speech, and sometimes it's nursery rhymes, and sometimes it's singing. And I know from nobody here, because we're all music-oriented and everyone's really good, but it's really interesting going into the literature, and sometimes it's all just infant-directed speech, and you're like, well, we could talk about that. There's also some really fun examples like this. This is from a study in 2014, so it's a little bit, but they said oh, it was a little surprising, we didn't see some differences in this. And then, I saw buried in their discussion, they're like, all of our study also included musical scores as a backdrop to our facial stimuli, because we thought that would increase kids' attention. Yeah, great, spoiler alert, it does. That's fantastic, but it's also a confound if you have music playing to all of your stimuli. And if you want to hear more about this, and in particular a much better job on that latter study, and hear about intervention implications, come to the talk tonight, which will be like 95% different, including all the jokes. I'd like to thank you all for your attention, our participants, and my colleagues and funders. Thank you.
We are now going to do Q&A for about 15 minutes for both of the talks we just heard, Dr. McCauley and Dr. Lense. Please. Oh, okay. Yeah, there it is. Yeah, okay. So we're going to do 15 minutes of talk for both of the two talks that we just heard. I'm going to run around. I saw you first pretty quickly.
So this is question is for Miriam. Thanks for the lovely talk. Sorry.
That sounds ominous, Erica. I'm not sure what you've got coming at me.
I actually had two questions, but you answered the one because we know that babies will attend more to the mouth for smiling compared to neutral or frowning faces. So I was glad that that was talked about after. But I'm actually curious. So for the well, it's kind of a two-sided question, but for the actresses, I was wondering how they were instructed to sing and engage in the stimuli. And I was wondering what your hypotheses would be if they would differ if they were singing to an actual baby, and if that would differ if they were singing to a baby at risk for autism. So in other words, is there evidence that parents of kids with autism might sing differently to their child?
Really good questions. My working memory is a little bit tapped, so I might need you to remind me of your first, what the singers were doing. Okay, great. They were instructed to sing to really, or to be engaging the infant and sort of using a variety of these sort of natural scenarios. Yes, it is a shortcoming that there was not an infant present. That was done for sort of a number of just sort of methodological, logistical reasons, and I know you work with infants and can think of what all those could be. Would they be different if they are actually singing to an infant and whether or not that infant is, has autism or is sort of going on that pathway? So my hypothesis would be yes. We are looking at that now. We have a very cool bidirectional eye tracking setup where we're able to look at both infant and caregiver, and we plan to look at that. I won't lie, we tried to do a mad dash to have some of that data processed for today, and we did not make our deadline, but hopefully that means we'll be close, and so I could have some things to share with you soon. So, it gets very complicated there's a whole number of reasons. So first of all, when there's an actual infant, right, you ideally should be responsive to whatever your infant is kind of putting out in that moment. And infants vary, and you kind of get different things. So that's one thing. Another is that all of these parents, in our sample, that's our elevated likelihood sample, they all have an older sibling with autism. So the parents have already had that experience, and whether or not that has any longer-term impact or anything like that, or how they're choosing to engage with song-burst speech, we don't really know. What we can say, most parents are they adapt, right? Like their parents are generally quite sensitive and are sort of adapting to what's going on with the child in front of them. And there's like a whole lot more I could talk about there, but maybe at break or something. Yeah.
Sorry, I have a question as well for Dr. Lense. I was really interested in the stimuli that you were using. And I think it's really cool because it kind of shows, for instance, in the speech condition and the music condition, like differences in attending. But I was also curious about, for instance, the familiarity with, for example, Mary Had a Little Lamb. And in the speech condition, it was like more informative, like we're going to be having broccoli for dinner. And I was wondering if you've explored, for instance, comparisons with more informative or less familiar music stimuli as well for attending?
That's a great example. So this, the big longitudinal study is all secondary data analysis, and so I don't have information on those kids on that familiarity. In our toddler sample, we do have information. We're still building that sample, but at the moment, we're not really seeing anything in particular. We're not really seeing sort of an effect of like knowledge of song, specific songs with autism. We don't ask parents like, have you ever said these words to your child for the speech condition? So that's a confound. Like, ooh, have you asked your child to eat broccoli, and how has that gone for you? So I don't know. I will say it's like a variety. It's there's like play scripts. Like it kind of does vary. I think it's a great point and an interesting question. And I know like Haley Cragness, who I feel like I saw. Okay, thank you. Has done work on familiarity and. Could, I'm sure, speak with you a lot more about that in terms of what, we have no idea in autism. I mean, I have hypotheses, but we don't have, specific things. So I think it's an ongoing question in regards to, how your familiarity with certain stimulus might impact not just how much you attend to something, but how you sort of allocate your attention and, is there sort of unique or unique differences or similarities compared to the way you've done it. But I would say also with things like song is kids are pretty good, and there was Angela's poster, right? Like parents in some ways can sing to kids pretty similarly, but there also are huge differences in how parents sing their songs to their kids, because to Erica's question, they are generally adapting, right? So like you may sing Wheels on the Bus all the time, but you're probably singing it at a different tempo or in a different way if you're like changing a diaper or distracting the kid versus like trying to get them to sleep. And then also the infants are often exposed to these songs in multiple environments, by multiple parents or siblings or caregivers or nursery providers. So it does get very complex to get into that, like totally getting their sort of audio-visual musical landscape in that way. But a really good point and a good question, and maybe I'll have more as we build our toddler sample.
Thank you so much.
This is a question for Devin, actually. I was just wondering if this internal beat deficit effect is really beat related, or if it's more just a general rhythm deficit, because it seemed like the children with stuttering group actually had like preserved benefit of the beat. So whenever the beat was really clear, they actually performed fairly well. But when it was less clear, then they performed worse, which is something we find in like the control group as well. Whereas, like, if you did something like the Parkinson's disease patients who don't get a benefit of the beat at all, so they actually have like almost equal performance between those two conditions.
Right. I think one important distinction is that like simple rhythms where you're consistently reinforcing the beat, that you have an external beat that's being provided to the participants. The complex rhythms where that's not always the case, that is what we predicted would be particularly taxed for the children and adults who stutter. And that's generally the same pattern that you see. You see a bigger difference between groups for complex rhythms than you do for simple rhythms.
I had a follow-up question to that.
That's great.
And also in the fMRI study, was the basal ganglia part of the network that showed the deficit in functional connectivity as well?
Yes, that used a putamen seed. So I was looking at areas connected to the putamen and the sort of correlated activity.
We got time for more questions if there are any.
So I have a general question I wanted to ask the Miriam in the group, if I could. So one of the characteristics of song is that it's got a slower tempo, and so there's the implication that sort of slower is better. But I think it's interesting that I don't think that's always the case, right? So because children have a faster preferred tempo, and one of the things that we found is that if I compare rhythm discrimination between children and adults at sort of more adult-like tempos, the children really tend to struggle if they're too slow. And in fact, to improve performance for the children, you need to speed up the rhythms so that they have a faster tempo, which is sort of the opposite implication of going from speech to song, where one of the characteristics is actually a slower tempo. So Miriam, I'd be curious your thoughts on the role of tempo and how it might be different, I guess, in different timescales. Anyone else's thoughts on this issue?
Sure, I can start. Also, I just want to give like a massive shout out to you, Devin, because you don't know this, but you are even like visually looking towards me, which is like kind of incredible.
No, I can't tell.
50-50 shot on like which side I would be on, and I'm feeling like synchrony, right?
Yeah, you're turned sideways from my perspective, so I don't know how that works.
I don't know if that's a sorry or you're welcome, but such as it is. Yeah, so I think I don't want to really give a value judgment to some of the differences that we're seeing in. Now I don't know which way to look, Devin, because I'm not sure where you are today. He's up there. Hey. I think it sort of depends what we're looking for. So, for example, I think there could be differences in optimal tempo, and sort of to the questions of. So familiarity questions before too, like you're gonna sing differently to your child, and tempo is a great way you modulate your singing, depending on if you want to be capturing their attention or not, and how much they're gonna be wanting to engage, right? Like if a child is like really, one of the therapeutic things sometimes people talk about in terms of using song, for example, like, well, not just with song, but you always kind of want to meet your child where they're at. And so like if your child is really amped up, and you're like, oh, I want them to calm down. If you just start singing like a slow lullaby, it's not going to work. They're just going to be super annoyed. It works better to kind of meet them where they're at, and then once you've got their attention and trained, you kind of slow it down from there. Sometimes it works better in theory than practice because kids are kids. But like in general, you're going to be sort of. So I think your idea of like what that preferred tempo is and kind of how can they best process makes sense. For something like attention to the mouth, we know from some other work that slowing down speech does increase attention to the mouth. And for kids who are like learning language and having to parse like the oral motor movements that are like helping for getting different phonemes, and then for children with autism who may have differences in processing speed and maybe using that signal differently, there's, I'd say, a growing body of work that slowing things down does help with some of that speech processing. But yeah, I think it's to continue, and I would turn it over to the room for other contributions to Devin's question.
Okay, Devin, can you hear me? Can you hear me?
Yes.
Yeah. Okay.
Yes.
Hi, my name's Tara. I was just wondering if you're thinking about like the role that basal ganglia plays in timing. I wasn't sure if maybe the kids who like faster tempos, if that has to do with like more excitatory and less inhibitory mechanisms. And I'm not sure if you know anything about like the development of inhibition. Like perhaps like as we get older, we can handle those slower tempos because we're not just wanting to keep going, but we're able to inhibit some movements.
Yes, no, I think that's an interesting possibility. And I don't think that can be sort of ruled out. I think also one of the interesting things in terms of older adults is that older adults do have a slower preferred tempo, but if you look at where rhythm breaks down for a lot of older adults, actually, especially those that are experiencing cognitive decline, it's actually a slightly faster tempo for those individuals. Rhythms, they can't hang on to longer time intervals and connect those events in time as well as younger adults. So there's sort of a U-shaped curve to some aspects of, I think, preferred tempo and development across the lifespan.
And then I think with that,
There we go. You got me now? Perfect. And I think we have one last question from home, wherever they are. It's Lindsay Hippe. And actually, I'm going to answer her first question, which is the public lecture you mentioned, the live stream tonight. It is. I will provide that link for everybody at home. But the question is for Dr. Lense. Thank you for such an engaging and fascinating talk. What are your thoughts on replicating this kind of study with live in-person stimuli as opposed to audiovisual recordings?
I think it's a great idea. I would love to do it. It brings up a host of technical issues, and I would maybe ask people to talk with Erica about some of those types of technical issues. And for some of the things, it's just more easier said than done, right? For specifics of visual attention, like we're pretty good at looking at, for example, in live, if children are attending, overall to somebody or to their face. Attending to specific regions like the eyes versus the mouth, that can sometimes get a little bit harder. And then with the kind of entrainment studies, once you have somebody singing live, you get bidirectional like accommodation and things like that. And so I think it's a really exciting direction. We're trying to work some of those types of things out. I'm like really, really excited by them, but the complexity just kind of goes up astronomically. So I think there's like a lot of these questions, there's so many great ideas, and I think there's just so many directions for this kind of field to go, and really thinking about kind of these really multimodal and interpersonal kind of components to these types of interactions.
All right, can we all thank Dr. Lense and Dr. McCauley for some awesome talks?